Okay, good morning, class. Today we're looking at data handling. Okay, we just looked at the example and the physical homework. Now we're looking at the semi-interquartile range. People, if we tell you something is a semicircle, what does that mean? Half. So semi is basically referring to half. Okay. So we're reading from page 18. And this is on exercise 13.8. For page 380. Okay. So now we're looking at the semi-interquartile range. Semi is the half of the interquartile range. How do we calculate the quartile range? The interquartile range. Q1 minus Q3. So Q3 minus Q1. So semi-interquartile range, Q3 minus Q1 divided by 2. Okay. So the semi-interquartile range is one half the distance between the lower quartile and the upper quartile. Semi-interquartile range is equal to the interquartile range divided by 2, which is the upper quartile minus the lower quartile. Also the 75th percentile minus the 25th percentile, or Q3 minus Q2 over 2. Okay, so yes, semi-interquartile range. That's your interquartile range. When the distance, so here we are told now, when the distance between Q1, when the distance between Q1 and the mean M, the median, sorry, it's approximately the same distance between M and Q3. The median lies halfway between Q1 and Q3. If the value of the semi-interquartile range is added to the lower quartile, which means to say to this here, the value of the semi-interquartile range is added to the lower quartile or subtracted from the upper quartile, the value of the median will be obtained. Okay? More than this. If the distance Q1 and M is not approximately the same distance between M and Q3, adding the semi-interquartile range will not give you the value of the median. Okay. So basically what they are telling you the data is lopsided, or it's the one end is bigger than the other. Okay, this is what I'm gathering from here. Then we are told that will not give the value of your median. Okay, so if it's, as I said, lopsided on one side opposed to the other. Okay. So now we're looking at other subdivisions. We're still on the same page. I'm on the next page now. So with that, you should be able to do 13.8. Okay, there's the one sum there that I want you guys to do 13.8. So now we're looking at the examples for 13.9. And 13.9 is on page 321. The example is on page 319. I'm reading from page 319. The example ESE is on page 320. Okay, but this here, other subdivisions, I'm reading from page 319. So let's go here quickly. Other subdivisions. Here we are told that the median divides the data into two halves. The quartiles divide the data into quarters, 4 quarters. The decile. People, what does decade mean? 10. Decagon? 10 sided figure. Decile divides the data into tens. Can you see that? So the decile divides the data into tenths, or 10 parts, equal parts. Okay. Percentile, we tell you percentage is a representation of 100. So the percentile is dividing the data into 100 parts, 100 or hundreds. Alright, you guys understand? Alright, so now we're going to look at that thing. So here we are told the median is a value that divides the data into two halves. There is one median. For example, is 7. 7 is the median of the data set. Okay. So if the number is odd, of course, there's one median. However, if the number is even, of course, there are two medians. But we spoke about that already in our previous lessons. Here we are told the quartiles subdivides the data into quarters. There are three quartiles, quartile 1, 2, or your median, and quartile 3. For example, again, we know from this data set, this gets crossed out, and there's 1, 2, 3, 4, 5 on the side, so that's your quartile 1 and your quartile 3. Okay, but that's your markings, but dividing the data into 4. Okay. Okay, so deciles. Decile is subdividing the data into tens. Okay, that's what I said now earlier on. There are 9 deciles called first decile, second decile, third decile, and so on up to the 9th decile. The last value, or the 10th decile, is 100% of the data, which is the maximum value. Okay, so that is why for your quartiles is also quartile 1, quartile 2, quartile 4 is actually your maximum value. That is why they don't mention quartile 4. Okay, so it's 100% of the data, or the maximum value. Okay. The word decile comes from the same root as the word decimal, meaning tens. For example, right, so you got the data set here, and you can divide your data into deciles. Okay. The percentile subdivide the data into hundreds. There are 99 percentiles, called first percentile, second percentile, third, and so on to the 99 percentile. The 100 percentile is going to make maximum value. The word percentile comes from the same root as percentage, meaning 100. Okay, the median in the second quartile and 5th decile and 50th percentile is the same, which means to say the halfway mark. You guys understand it? Okay, the 50th percentile is half. The 5th decile is 5 over 10, which is also half. And the second quartile is also 2 over 4, which is half. Okay. The lower quartile, 25th percentile, and the upper quartile is the 75th percentile. I think I mentioned this quite a bit when we were doing your box and whisker diagram. Okay. So now we're looking at the example on page 320. Right, and this is for exercise 30.9. Okay. Is that in my pocket? Alright, so here we are told that 45 grade 10 learners were asked to estimate how long they thought a minute was. Okay, so basically what happens is you sitting 2 people opposite each other, and the one is sitting with the clock, and you ask your friend how long you think a minute is. So if we're sitting 2 people now, né? Person 1 and person 2. Person 2 is sitting with a stopwatch. You ask person 1, tell me when to stop after when you think the minute has lapsed. So if you say when the person 2 press, right, person 1 goes and goes in. You say, okay, that's a minute. So he stops and he checks the stopwatch. Okay, that's basically the experiment. Okay, they indicate when they thought 1 minute was up, and the partner recorded the length of time. Okay, connect to the nearest second. So person 1 doesn't have a clock. Okay, and then you rotate, and then person 1 again measures, And in person 2, guesses. Okay, you guys understand? Alright. They indicate when they thought 1 minute was up and departed recorded the length of time. Correct to the nearest second. The estimates are as follows. So how many people are here? 40. So the question says, so here's all your data now. Is this data number 1 in order? No. What do I have to do first? You must get it in order. When we're reading quartiles, percentiles, deciles, it must be in order. You guys understand? So, let's go. Where do we start? This lowest value. I'm seeing for 42. Sorry? 44. No, 42 is the lowest. Yes, so 42. Then 44. Then? Sorry? 46. I think the quickest is going to be is to draw a stem and leaf. It's going to be the easiest. Okay. Right, so the smallest was 14, eh? So it's 42, then there's 53, 47, 77. Can somebody read for us? 6, 7, 8, 9. 77, yes, 63, 59, 54, 62, 65, 71, 77, 58, 67, 51, 72, 57, yes, 48, yes, yes, 46, yes, 51, yes, 50, yeah, 63, 68, yes, yeah, 65, yeah, 53, yes, 71, 73, 56, 69, 44, 56, 77, 58, 55, 79, 56, sorry, 58, 67, 52, 48, 48, yes, 17, yeah, 49. Did I miss something? Huh? The 77. Is this wrong? So it must be 67. Okay. Let's sort out this data, thank you. Let's sort out this data quickly. Okay. So it's 4, 5, 6, 7. So we got 2. 42, then 44, 46, 47, 2 8s, and a 9. Okay. Now, there's 2 zeros, 2 ones, 1, 2, 2 threes. I'm missing a 3. Sorry? Well, it's 2 threes. Yeah? 2 fours. Yes? 1 5. 3 sixes. 1 7. 3 eights. 2 eights. Okay. Yeah, we got the 1, the 2, and 2 threes. The 1, the 2, and 2 threes. 2 fives. 2 sevens, and a 9. A 0, 2 ones, 1 2, 2 threes, 3 sevens. Okay. Just check according to the book if that's correct. Sorry? 58. Is there 3 8s? Okay. So it's 8 and a 9. So let's count. How many values are here? 45. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay? 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44. We are missing a number. Okay. So just to save some time, they have put the numbers in order there. Just check there. On page 320. Okay. 68. Just check there if that's there. Right. My mistake, sorry about that. Alright, so these all are numbers now. Okay. So the first question says calculate the 8th percentile. People, what is percentile? The representation of 100. So you're going to go the 8th percentile is going to be 8 over 100 multiplied by how many values are here? 45. So it's going to be 8 over 100 multiplied by 45. You 3,6. So the 3,6 is approximately the fourth number. You guys understand? So it's going to be approximately the fourth number. So we count 1, 2, 3, 4. So therefore the number is 47. Whatever this represents. No? What is this? Seconds. Can you see that, people? Let's look at B. The 20th percentile. So it's 20 over 100 multiplied by 45. So you got 20 over 100. It's going to give you the 9th number. So it's the 9th number. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 50 seconds. You guys get the idea? No? That's the next question. 95th percentile. So what's the calculation for the 95th percentile? 95 over 100 times 45. That is 95. It's going to give us 42,75. Number, no? So therefore, 42,7. Which is approximately the 43rd number. Not so. So let's go. So the end of this class is 25 here. Oh, that this one is 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. Or I could have said, okay, this number is going to be the 45th, 44th, so 43rd number is. Okay, anyway you want to go. So therefore it's going to be, what the number? The old number, so we're getting quicker. D. The 8th decile. People, decile is what? Over 10. So it's 8 over 10 multiplied by 45. It's approximately, so it's 8 over 10 It's going to be the 36th number. So you count 36 now. There's 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So it's going to be 70. So 70 seconds. Right? You people guys understand? Any confusion there? Alright, so the use and abuse of statistics in real life, in the real world, you guys can read through them. Okay? So that we are running, and there you got your misleading graphs or your misleading data. I've done this in in last year's lesson. You can find this discussion in the description box below. Okay, but we need to start probability in our next lesson. Okay, so you're going to read through this. If you don't want to read, you can go through the last year's lesson, and then you can take it from there. Okay. So this basically brings the statistics, so data handling to an end. Okay.